And looks like we're live. Okay. Hello, everyone out there. We have a lot to talk about tonight. Rain? Yes. We have the potential for rainfall to invade the region, which could potentially break the drought. But I'm going to also share some of the factors that make me a little bit skeptical, just a little bit. So I'm going to explain that tonight. And of course, we're going to go over our book of the week, a technical book, but one that is very fun. And of course, we'll keep an eye on the Mets, see how they're doing. They already won the first game, so if the goal here is just to win the series. So considering they don't have a real starting pitcher tonight, I'll give them a mulligan if they lose, but we'll keep an eye on it. So first things first, of course, just to remind you, we'll answer all the questions that are in the live chat here first, in the premium live chat. And then after that, we'll go visit the social media. I already saw a couple of really good questions on YouTube that I'm definitely going to jump on. So we'll definitely do that. And then we'll go from there. But first things first, we got to talk about my book of the week. Ta-da. Here we are, Applied Thermodynamics for Meteorologists by Sam Miller. You can pick this up pretty easily on Amazon. It's from Cambridge University Press as well. You can also look for it on cambridge.org. S. Miller. Oh, and the Mets just hit a home run. Vientos. Very nice. Good job, buddy. Okay, so why is this book so awesome? Well, it has very detailed, very well explained mathematical equations. And believe me, when I'm working on my CCM tests, these are very important. And you have to reference the books as well. So you better make sure you have the right books. Now, if you're a young meteorologist, if you're just starting out, this book might be a bit much for you. But if you like a challenge, or at the very least getting used to looking at the relationship between the equations and the physical forcing, this book is for you. Even if you don't understand the math initially, it does a great job of explaining a lot of the forcing mechanisms like entropy and explaining how these equations basically play into the model guidance that you use. So by starting to understand these important factors like vapor pressure, for example, very important. And let's see, God, oh, good. This one shows like the critical points between where water vapor is maximized and how that evolves. Why is this so important? Well, look, everyone and their grandmother is all up in arms and all excited about AI. And yeah, it's a great tool, but it has limitations. And if you don't understand the physics involved, well, the AI model is garbage. So you want to just, run around and, just listen to whatever the AI model says, which is a error. And look, it's like no one ever pays attention to sci-fi movies. AI is never the foolproof idea that you think it is. It has the potential to be something really good, but at the same time, Terminator, Skynet, that type of stuff. So, just put that in the back of your head. But overall, this is a great book because it just does a great job of explaining a lot of important themes. And I think if you want to, if you have a child who is getting ready to go to college for meteorology or is just interested in high school, pick up this book anyway. Because believe me, you're going to need it when you're in college and you don't want to spend it at the bookstore at the college. You can buy it on Amazon for a little bit of a discount or on the American Meteorological Society. It's a nice gift anyway. Save you quite a bit of money as well for some of those expensive college books. So that's my book of the week. If you have any questions about it, again, it is Applied Thermodynamics for Meteorology by Sam Miller. There you go. Now, let's talk about rain. We haven't had much, right? It's been hit and miss. This month, it started out okay. It started out, hey, look, we got a little bit of rain, maybe pushing near normal, getting a little bit out of drought conditions, and then we kind of fell back. Most locations end up with slightly below normal precipitation totals. I think a few locations, like around Trenton, got close to normal or just slightly above normal at like 0.1. But for the most part, from what I've seen so far, pretty much below normal, and temperatures were actually averaging above normal. How did that work out? Well, we had plenty of days where it was spiking 15, 20 degrees above normal, and a couple of days when we were slightly below normal. So that averages out to above normal overall. So, what can we expect for May? Well, we've been talking about this for quite some time. And so let's dive into the data. First of all, our current observations. Absolutely beautiful out there. We have temperatures in the 60s and 70s, and we have a light wind coming in from the north with high pressure in control. It's beautiful out there. So, if you're heading out to a ball game or you are at a ball game, if you're watching this and at the ball game, that'd be really weird. But at any rate, it is beautiful outside. And that is because high pressure is in control. You can see the mid-level ridge is is approaching our region. So what you have here is a nice convergence and confluence that leads to sinking air, leads to pleasant weather conditions. Enjoy them. But trouble is brewing. But before we understand why we have trouble brewing, we need to understand the forcing mechanisms that are driving our whole weather pattern. And believe me, this is something I'm going to be watching as we move towards the summer because it gets a little complicated. Why does it get complicated? Well, in previous summers we had El Nino, we had La Nina, we had El Nino, La Nina, La Nina, El Nino. But not much in a way neutral, right? It's been a while. Not only do we have neutral Enzino influences, we have neutral MJO influences. This is the whole forecast for the European guidance. And you might be noticing I'm leaning a lot on the European guidance of late. The reason why is that the GFS, based on statistical analysis on how well it verifies, has fallen into the toilet. And I'm not just saying that because I don't like the GFS model and the way that they run the physics in the model. I mean, look, everyone has their favorite model, whatever, but it literally is in the toilet. It's probably one of the worst models that has been performing over the past 2 months. So I'm staying far away from that model guidance and leaning more on the European ensembles and European AI. You can even use the Canadian. Canadian's performing better than the GFS right now. You can even use the UK Met, no gaps, the NJM model. Let's see here. What else? A Sun and Dial would be better than the GFS at this point. So you get my point here. I'm staying away from it. So what is the European guidance showing us in the long range? Dead neutral. When the MJO is in this circle here, it's bye-bye. It has barely any type of influence on our weather pattern. It's pretty quiet. Okay, so we don't have the MJO. We don't have El Nino or La Nina. Well, let's take a look at our SOI. Well, wouldn't you know it, that's trending towards neutral as well, which shouldn't be a surprise considering all the other tropical forcing mechanisms. So we don't have a lot of forcing mechanisms via a tropical influence, which is okay. It might scare some meteorologists, but for me, I like the challenge. Let's see what we could do here. So what other forcing mechanisms? What can we think so outside of the box? Well, let's take a look at the stratosphere. Well, wouldn't you know it? It's rather chilly over eastern North America. Now, this is at 50 millibars. You could take a look at the observations at 70 millibars on NOAA, basically showing the same thing. So we have currently cold anomalies over eastern North America. Let me zoom in here. Warm anomalies over northern Canada. Warmer anomalies starting to form over the northwestern Atlantic. Cold anomalies over the western Atlantic. Interesting. Well, let's see how this plays out over the next 15 days on the model guidance. All right, so it swings across. We have cold anomalies focusing over North America, some warm patches here and there. So what does this typically mean? Well, when the stratosphere is cold over your location or over the continent, okay, that enhances your 500 millibar heights. Why is that the case? When the stratosphere is cold, it contracts. And so when the stratosphere contracts, it can't pull out of space. It has to shrink this way. So when it shrinks this way, what happens? Well, the troposphere expands. When a troposphere expands, that means rising 500 millibar heights overall. Now, that doesn't mean you can't get an upper level low in this scenario, but it means that the 500 millibar heights overall, the overall theme is rising, right? Meanwhile, the warm anomalies, well, that means expansion. And so with the expansion, again, it can't expand out to space, so it presses down on the troposphere, leads to below normal heights in the troposphere. Where we see that most? We see that most in the northwestern Atlantic. So this type of scenario would lead to a persistent, pesky negative NAO. But remember, we have to displace this further north. It's not the same as like the winter and negative NAO. It's displaced further north. So it leads to more building of 500 millibar heights here and here. So you got below normal heights here, above normal heights here, here, and here. So this could lead to a nice southerly flow. But it also means in this scenario that you can get these cutoff upper level lows. Now, how do we develop these cutoff upper level lows? Well, what happens is that the polar jet stream's retracting. Okay. Now, let's just say you have a bunch of school kids, right? And they're all on a line. And most of the school kids follow along with the school teacher, and they go towards the library or towards the museum. But you always get that one kid that's always hanging back because they saw a bug or something on the sidewalk, and they decide to hang back, and they get displaced from the line. Well, here is your kid with the bug right there. That's essentially what's happening here. And so the cold stratosphere loft, it enhances this process because what's happening is that you're getting some of that cold air in the lower stratosphere and upper troposphere to bleed down and mix, and you're destabilizing the atmosphere even more. So what that process does is that enhances the potential for these upper level lows. Now, the problem with these upper level lows are they are a pain in the neck to forecast for. Very, very difficult because they tend to meander a bit, and the evolution and formation of these upper level lows are difficult to lock down. And a slight shift to the southwest or northeast or east west can create a significantly different forecast than what you have right now, which is why I was saying in the public forecast that my confidence is low for next week. Yes, it looks like rain. Yes, it looks like a lot of rain, maybe, but my confidence is low because this evolution, if it shifts a little bit further to the southwest, I'm not talking about a lot. Let's say instead of Indiana or Ohio, it ends up in Kentucky and western Tennessee, like right around here. Well, then that means that this ridge is positioned more over here, closer to the Gulf of Maine. And that means a high pressure system is building down into the northern Atlantic, and we just have scattered cloud cover, and that's it. Or it aligns just like this perfectly, and we just get moisture surging in. So I've been keeping an eye on the model guidance, and yeah, I decided to bring up the AI guidance just to kind of compare and contrast, see what we're seeing here. Now, the AI guidance, remember, is based on statistical analysis and what is most likely based on that statistical analysis. It doesn't do a great job in terms of physical processes, in my opinion. So, again, take this with a grain of salt, but it's very similar to the operational guidance. It's a little strong, in my opinion. It might be a little bit too strong, but it definitely has the same type of process, same type of evolution. Notice in this whole setup here, you have your polar jet stream up to the north, and really, on average, your 500 millibar heights surrounding this upper level low are pretty high for this time of year. So overall, the colder stratospheric environment leads to above normal 500 millibar heights as the overall theme, but then these upper level lows get cut off because the kid decided to go check out a bug rather than following the rest of the polar jet stream. So it's kind of hanging out around here, and this is what leads to transport of moisture. But again, the location is key. The European ensembles guidance shows basically the same type of theme playing out here. Very, very similar, very close to the location. And the reason why, again, this location is so important is this area right here. You see how you kind of have this spreading here? This is called divergence and diffluence, okay? Where this sets up, it leads to rapid rising in the atmosphere and can enhance precipitation. Basically, it enhances lifting along the stationary front that's going to be meandering around the northern mid-Atlantic. If this is slightly further south, then that lifting is focused more towards Virginia, and this ridge axis here is centered more over Connecticut and influencing the northern mid-Atlantic. So again, a slight shift, just a little bit, just a tiny little bit, and you end up with a completely different forecast. As we get below 120 hours, confidence improves and increases, but I'm just trying to share with you exactly why we can't jump the gun just yet on this scenario, but certainly a lot of interesting potential. So this is the moisture transport, okay, in kilograms per divided by meters per second, okay. What this basically means is it gives me an idea of how strong the moisture transport is in the atmosphere throughout the atmosphere. So, as we look at Saturday, pretty strong moisture transport, setting up the potential for showers and thunderstorms. We'll talk about that severe potential in just a moment. And then you see the upper level low evolve. And on Sunday, you still have that strong moisture transport from the south. On Monday, it transitions to the southeast, and this is where things get tricky. This is where things get interesting because now you're getting a moisture transport from the Caribbean and the Bahamas right up into the East Coast and also from the Western Atlantic. There's our ridge that's blocking everything up. Here's our upper level low. Again, this is why location is key because if this moisture transport is shifted further south or further north, we don't get anywhere near as much rainfall as what's being projected. So this is just a moisture transport, and this continues to linger on all the way through Wednesday. So this is why we're seeing the type of rainfall that we're seeing on the mile guides. So this is why we're seeing this shift in a much wetter forecast because of this moisture transport. Again, location's key. We have to make sure that this evolution continues to remain in place to verify this forecast. So this is where we are right now. And what I want to show you is the nature of the thunderstorms and convection here in the southern plains and the Mississippi River Valley. Now you might be saying, Stephen, why the hell do I care about this? Understanding where we are at can tell us a lot about where we're going. And there is a lot of instability in the atmosphere over the plains here. There's a lot of rising motion, a lot of divergence and diffluence, a lot of powerful dynamics involved here. This tells me, hey, this cutoff upper level low has some punch to it. It's not, being over forecasted here. It is basically bringing the goods. Okay, so this tells us quite a bit about that potential. We'll jump to the infrared satellite picture, and you can see that strength in the forcing here. Very impressive. Nice, strong convective development here, but also back here as well. So this is starting to evolve and cut off. So you're seeing what the potential dynamics are. And then when you take a look at 250 millibar winds, let's zoom in here. Here's our polar jet stream up here. Here's the beginning of the cutoff taking place. Here's the process taking place. Because of that process, you see this? This is an amazing example of divergence. Understand what's happening here is that because of the divergence, air is rapidly rising, which is enhancing thunderstorms, which is increasing the latent heat release, which is enhancing the clash of air masses and enhancing the potential for this feature to cut off. So this tells me that the idea of an upper level low cutting off and remaining strong is well supported in the current observations. We needed to study this so that we understand that, hey, look, the model guidance isn't full of it. It actually has a strong shortwave here. The cutoff is evolving. Everything is pretty much being backed up by the observations. So we're seeing this in the observations. Again, water vapor, very impressive. And you can also tell the strong lifting not only by the convection, but by the strength of the dry air behind it. Because remember, when you have rising air, it must sink somewhere, and it is sinking, that is for sure. Very impressive. Meanwhile, we have our nice ridge is starting to take shape here. And the other block is starting to show up here. So everything's kind of evolving pretty much as expected. So when I take a look at the 500 millibar PVA, we're going to now start focusing in on the severe threat for Saturday and what we're actually looking at here. So on Saturday, we have this positively tilted trough. Again, that whole evolution is starting to take shape here. You can see it all playing out. And there's our cutoff upper level low, all taking shape. Pretty well supported. Mid levels, seeing strong lifting showing up here on Saturday. Generally off to our west and creeping east. And we have plenty of moisture to work with as well. Now, what's the one thing that is consistent on Saturday? Everything's a southwesterly flow. So we're not going to be seeing much in the way of vertical wind shear, okay? Because winds are from the southwest at all levels. So that's uniform, okay? You see plenty of moisture transport, okay? So when I see high levels of precipitable water value, that increases the potential for some frequent lightning, maybe some vivid lightning, but it also increases the potential for downburst wind gusts if I have some cold, dry air aloft mixed into this whole scenario. So we certainly also have the Cape values here. Not impressive, but still pretty strong compared to what we've been seeing for this time of year. Over 1,000 joules per kilogram, you're in the game, okay? So the environment on Saturday is pretty well established here for thunderstorms, but are they going to be severe? Well, in terms of just mixing down the winds, not very impressive. In terms of vertical wind shear, not very impressive. So I don't really have speed shear. I don't really have vertical wind shear here. This is not impressive at all. But I do have this right there. Why am I so impressed with that? Well, if I'm lifting my precipitable water values and I have a thunderstorm and it's lifting into some of this drier air here, colder air here with, Cape values over 500, possibly pushing as high as 1,000 joules per kilogram, that can open up downburst wind gusts. So on Saturday, I see most of the day on Saturday isn't too bad. A few isolated showers here and there in the morning and in the afternoon, but then towards the later afternoon and the evening, because the lifting starts to enhance because the 500 millibar heights are falling, scattered showers and thunderstorms will become more widespread, and some of those thunderstorms are going to feature strong downburst wind gusts. You're not going to see widespread severe weather, but a couple of these thunderstorms are going to be capable of producing those wind gusts up to 55 miles per hour. I would not be surprised because of the downburst nature of this type of scenario if we get a few mesolows and some false positives in terms of tornado warnings, but really the focus is straight line wind potential via downburst wind gusts over 55 miles per hour. It's going to be isolated, but it's going to be a threat. There's also very, very small threat for hail, but the primary concern here is going to be the heavy downpours and then lightning. And so over the next 90 hours, it's pretty quiet all the way on through Friday. Again, you got some passing showers here and there with the warm front, but nothing really impressive. Most of the day on Friday is quiet with just a few pesky isolated showers. Saturday morning, same thing. Action really picks up after 2 o'clock. And then we see this evolution really start to play itself out with waves of showers and thunderstorms. The focus here is not severe weather. The focus here is the rainfall potential. Because as you can see, then we just keep on going wave after wave of rainfall. And one thing I'm going to show you, but I normally don't show you, is the QPF output. Why am I showing you this? Am I saying that we're going to see 6 inches of rain in northern New Jersey? Well, I wouldn't put this out as a forecast, but you can use it for something else. Look at the nature of that precipitation shield. Kind of looks like it's a V, right? It's kind of spread out. What is this telling us? Well, let's see if we could draw it. Let's see here. All right, so I'm going to draw my little thing here. Let me fix this here real fast and get this and this. All right, so it's kind of like that, and it's kind of like that. Well, that looks like a V. That looks like divergence and diffluence. Where is it diverging from? Well, we have our high pressure system here. We have our low pressure system down here, and we're caught in between. So this whole setup is driven by divergence and diffluence, with the strongest lifting here. In fact, let me put this red on right here. So the lifting that's taking place here, that is what's leading to this heavy rainfall. So now we have an idea, based on everything we're looking at, and via this map, what the overall theme is. If the upper level low lines up just right, we get the right moisture transport and the right divergence and diffluence, we can say goodbye to this drought. If it's off by just a little bit, then we'll have scattered showers, but it won't be as impressive. So, kind of column A, column B, in terms of whether or not this is a good thing. We don't want 6 inches of rain because that's flooding and it will just wash off the topsoil. But we do want rain. So, 1 to 3 inches of rain, good deal. I'll take that in a heartbeat. And it certainly is a good start to our May rainfall totals for the month. So there's a lot of potential here. I think that it's something that we really have to watch out for in terms of our location of this upper level low, but it certainly opens up the potential for a rather stormy period for us. And plenty of time for me to read my book and work on my CCM test because I'm going to be indoors doing that. So now that we got all that done, now it's time to answer your questions. So that's what we are going to do. Let's see here. Of course, we're going to start off with the premium chat. And let's see where we're at. Yankees are on Amazon, so don't get to watch them tonight. Oh, that stinks. I think they might be losing, unfortunately. I don't know. I'm not trolling. I'm just saying I think the last time I saw it was like 4-2 on SNY. Good evening card. Let's see here. For minimal tropical forcing, the 250 millibar jets are ripping and roaring. That is a great point. Okay, so why is that the case? I think that still has some influence from our volcano from a couple of years ago. I think that is a factor. I also think the changing dynamics in the stratosphere is influencing some of the thermodynamics involved with driving that jet streak. But I think also there are so many lingering influences, kind of like a ghost hanging around, that still is supporting some enhancement of that 250 millibar jet. So basically, the ozone pocket forecast each week will be a key read. Yes, absolutely, which I will have on Friday. Now that we're adding that to solar, I found some better data, more reliable data. Non-weather topic: Aaron Judge's numbers going into tonight. He already has a home run, 31. Wow. Okay, Aaron Judge is having a good season. Good for him. Now all they need is some pitching. But he's an okay player. He's all right. He's okay. Should I be concerned if the AI says it's full confidence in the mission or accents where Sarah Connor is? Possibly. Boy. I'm not saying it's a scary world, but sometimes it's good to ask, hey, is it a good idea to do this? Just saying, you know, especially with cloning and stuff. Now they're going to try and clone dinosaurs. Give me a break. Aaron is asking, Steve, assuming the weather solution is correct, what sort of flooding would be would we be looking at? Many river flooding, I assume. Yeah, we'd have to really keep an eye out on northern New Jersey. Um, See, the problem with all that rain is that the banks are going to be overwhelmed pretty quickly in that type of scenario. But another thing is urban flooding. You might be saying, Stephen, why do I have to worry about urban flooding? Because it's been dry and people drop stuff in sewers because they're people, and that blocks sewers up. And so you have a blocked sewer, which guarantee they're not checking completely. That's going to lead to flooding. So that is another concern. Let's see here. Card actions. What are the factors that would lead the upper level low to cut off further to the west or south or east or right where it is forecast for right now? It's basically the way that it cuts off from being a positively tilted trough to an upper level low. When that process starts to solidify, it could easily shift. And again, we're not talking about a huge shift, but just a slight shift, a slight wobble, and you end up with different forcing parameters. I'm not saying that will happen. I'm just saying that that is my concern. That's the volatility in this forecast, is that wobble as the upper level low develops. Um, that's why it's such a tricky situation. How does rush hour Friday morning look? Um, Rush hour actually on Friday morning and Friday in general, not too bad. I mean, a passing shower here and there, but overall, nothing that would create any major issues. Your real main issues in terms of travel is going to be on Saturday and Sunday for the weekend. Saw a piece on the volcano that talked about how the force of it reached satellite level in space and actually impaired satellites in orbit. It did create, like, definitely. I heard about a gravity wave that impacted some of the positioning of the satellite, and there's definitely been that factor. That volcano had a lot of impacts, as I warned, and Mother Nature could be a real pain in the neck, that is for sure. Any thoughts on the tropics? Stay away from any extreme forecasts. That's my. I'm already seeing some nuts running around there. Um, I don't like the idea of extremes, especially this year. I will have more out there, but I can guarantee you it's not going to be anything historic. I don't think this is going to be a historic season. The one thing I'm struggling with is just the Western Atlantic Ridge to see what that looks like. I'm working on that. And then once I get that knocked down, then I'll be able to issue the forecast. So that's why I'm shooting for mid-May, because I want to I'm reading some research papers first to get that knocked down. Also, all the chemicals and oils on the road get lifted up by rain, making the roads doubly slick. Oh, yeah, that's a good point. And that's why we are not going out on Saturday and Sunday. We're going to stay in. Yeah, right? It rains, and people think that, hey, look, we're going to go and race our cars now. I don't get it. Don't understand it. But I will say this, we are going to get all our stuff done on Friday, get everything done. Then I'm going to come back. I'm going to grill hot dogs. And we're going to have fun. And then we're going to have 60 hot dogs. And we're going to have a hot dog eating contest. What do you think? No? I'll have 60 hot dogs. And I will see if I can race myself. There we go. I'm the grill master. Let's see here. Would convection be a factor in a wetter solution or stratiform stuff? Good question. Okay. Initially, the Saturday event, that's going to be convective driven. For the rest of the event, it's going to be a lot of stratiform rainfall, but then where some of the elevated thunderstorms set up, that's where you're going to see those bursts of heavier rainfall signals. Some of these 4 or 5 inch signals that are showing up are driven by perfect divergence and diffluence, coupled with a perfect jet streak at 850 millibars, and 700 millibars, driving the moisture transport. It's perfect alignment, and so that's why you're seeing that. Think of it kind of like basically like a fire hose going right into the northern mid-Atlantic. Let's see here. My ex wants me to help her with doing some yard work in Wilmington, Gloucester, Saturday morning. Am I foolish to even attempt this? Um, Saturday morning, you'll be okay. It's Saturday afternoon where things go downhill fast. So you want to be done by 11 a.m. and noon. What does Saturday around noon, mid afternoon look like? Have regularly check up at the dentist. Okay, so overall, not too bad. You'll see definitely cloudy, increasing threats for rainfall. The heavy, steady rainfall and the thunderstorm potential is going to be more like let's say after 3 p.m. And then for 3 p.m. on, it'll get more and more coverage. Now, let me jump to YouTube. Holy smokes, look at this. Well, all right. So Mac asked a really good question. I want to see here. My question surrounds around last weekend's severe weather. This was a tornado warning for Ocean County, New Jersey, which is where the wildfire was. It got me wondering how wildfires influence severe weather. This is a great question. Okay, this is a good one. Okay, so the wildfire, okay, it's rising heat. Okay, we all know that. So we have heat rising, and yeah, you can get turning in the atmosphere because of that. You would need to have the thunderstorm move right over or very, very close to the wildfire. I don't think it was, but in theory, you have rapidly rising air, okay, which sometimes produces what we call fire tornadoes, okay, which does happen at times. And because of that rapidly rising air that is also twisting and turning while rising in a cyclonic motion, that can certainly lead to the potential for those type of severe thunderstorms. Let me just make sure I got this right on YouTube. Okay, good. So in theory, yes, it can influence it, but I can't say it influenced that thunderstorm in particular. Which does lead me to just point out another thing is that our technology has gotten so good that we can start to pick up these mesolows. And I get the idea of why you want to aggressively warn of a thunderstorm. But at the same time, I think that we're going to see more and more false positives as we move on through the next couple of years because our technology is so good. And you don't want to not warn for a circulation in a thunderstorm because the one time you don't, that's going to be the time when you actually get a tornado and people aren't warned. But I think that's what we're seeing more and more of. We're seeing better definition of these vortices in thunderstorms, and we're learning that they're happening more than what we thought. So we get a lot of these false positives, and it moved off the coast pretty quickly. So that's always good news. But the fire itself, it causes rising motion, certainly causes the enough lift to allow for that thunderstorm to be enhanced by that lift. But I can't say in that particular thunderstorm that that's what happened. Let's see, where we did April already. Take that hat off. No, it's my feed, and I'll wear my hat if I want to. Besides, I look good in it. It's a damn good hat. I've had this hat for 40 years, and I'm going to suffer with it for as long as possible. Let's see here. How bad will it be Wildwood, New Jersey on a Saturday evening? And definitely showers and thunderstorms. I don't expect severe weather there, but definitely expect a higher potential for rainfall. Uh, which day is a better chance for heavy rain, Friday or Saturday? Saturday, definitely. And on Saturday morning versus afternoon or evening is the highest threat. Why did the Yankees play in cold, heavy rain on April 11th, but they canceled the game on April 26th with scattered showers? I don't know. I would assume beer. They didn't consult me. They didn't ask me. Look, Major League Baseball should just ask me, and then I'd fix their problem. But they don't. So, what am I going to do? Is it easier to forecast winter storms or summer storms? I love winter storms more. I get more excited with them. I'm more interested in them than summer storms, if I'm going to be honest. Severe weather, I mean, look, I did my chasing, all that stuff. It just doesn't give me the same vibe as a snowstorm does. With that said, they're both very difficult, but severe weather has a lot of mesoscale well, most of the mesoscale factors that makes it very difficult to be pinpoint on a lot of things that some people look for. When I try to explain to them, like, look, this is convective weather. You can't have a pinpoint for it. Like, I can't tell you that a thunderstorm is going to hit you 3 days from now for your birthday party or wedding. Can't do that. All I could do is tell you, yeah, there's going to be a threat for thunderstorms. Some people don't understand that as well. Really appreciate your deep analysis and explanation, given real insight into the forecast. Thank you, Steve. I appreciate that. What solutions are you leaning towards? Widespread heavy rainfall lasting multiple days or scattered showers? I'm thinking right now, and again, I have the right to change my mind based on the data that comes in, but I like the idea of scattered showers with some heavier downpours pushing our rainfall totals in some spots over 3 inches, but most locations are going to be in that 1 to 2 inch range with several days of scattered showers. Okay. And some of those showers will be heavy. I am not convinced yet of the rain, the fire hose that drops 6 inches of rain in northwest New Jersey and northeastern Pennsylvania. But I also can't rule it out yet because that solution is a perfect evolution, perfect setup of perfect divergence, diffluence, moisture transport, all coming together at just the right time. Can I say that it won't happen? No, but it's most likely a little bit overdone. But again, I'm going to keep an eye on it. Long Island probably won't see thunderstorms on Saturday. Again, your time for thunderstorms on Long Island, severe thunderstorms or even strong thunderstorms, typically June. You have to kind of get over the influence of the Atlantic Ocean and maritime air mass. A junior in high school, I'll be deciding on which atmospheric science college university to attend within the next year. Do you have any options on which school have a better program? Okay, I'm going to tell you something that no one's going to tell you. Huh? I know. I know. I'm going. This is my opinion. Okay. Um. Oh, opinion. Okay. All right. So, don't worry about the name of the school. Worry about how do you learn best. Look, the name of the school matters for about 15 seconds when you apply for your first job. After that, it doesn't matter one iota, okay? What matters is, are you comfortable in a large setting or do you need something more concentrated? Are you comfortable with being in class with like 300 people or do you need something where it's more like 30 to 10, small class, well organized? Do you mind getting taught by a person who is just 4 years ahead of you, as in a TA, or do you want to focus on getting taught by an actual professor? These are the questions you have to ask yourself. Do you need a lot of access to tutoring, to asking questions of your professors, or are you used to just kind of figuring out the answer on your own? Are you comfortable with living away from home? Or would you rather stay a little bit closer? Now, you might be saying, Stephen, what does this all have to do with meteorology? Mental health and how you learn helps a great deal in how well you do in college. The name doesn't matter. It's all the same stuff in the book, okay? Just because you go to Penn State or Texas A&M, this doesn't change. This is the same. It doesn't freaking matter, okay? The other thing, too, is what do you want to experience? Are you interested in severe weather, lake effect snow? If you're interested in winter storms, then Rutgers might be a great option. Lake effect snow, where I went to, is SUNY Oswego. I love that. Penn State is a good option if you don't mind the large classes. If you're interested in severe weather, Oklahoma University, Texas A&M, Texas, all that good stuff. So really, it really comes back down to what are you comfortable with? And then you go from there. But good luck. And hey, don't worry about the SATs and the ACT and all that stuff. You'll do fine. Don't just my suggestion for you, if you are just about to take that test or you haven't taken it yet or whatnot, don't worry. Don't stress over it. That's the worst thing you can do. You're smart. Don't worry about it. It's fine. A lot of those questions are ridiculous anyway, especially the word problems. A waste of time. Let's see. Let me go back here. A lot of questions tonight. Let's see here. Uh, did you see the tornado warning last week? But yep, we just talked about that, Aaron. I found it to be interesting. Um, you always talk about PVA. How come we never hear about NVA? Oh, that's basically when the storm leaves. Negative vorticity advection. Basically, whenever I'm talking about dry slots, stuff like that, that's NVA, essentially. Positive vorticity advection is what gives you all the rain. NVA is what gives you all the clear skies. So the sinking dry air that's on the water vapor satellite picture, that is NVA. Do we have any questions on Facebook or X? Is X going to give it to me? Let's see what we got. Oh, yeah. Okay, let's see here. All right. Please explain going from great weather next week to terrible veto rainy. Okay. I don't know. Somebody terrible veto. Okay. Rainy weather. Can the models be wrong? Cutoff lows in May are horrible. Can the models be wrong? Absolutely. That's why they're just models. It's just tools. Um, but how? Well, originally a couple of days ago, the positive tilted trough didn't cut off fully. So you just basically had a strong cold front, and that's about it. The cold front idea has been the same for Saturday for some time, but that is about it. Um, Rain in New Jersey Friday AM, Thursday early afternoon. Okay, so basically, I'm looking at rain really taking hold late. Well, not even late Friday. It's going to be isolated all the way through Friday. If you're going to be looking for rainfall, steady, widespread rainfall, it's not going to be till late Saturday afternoon and evening. Let's see here. We already did the comparison for April. May, I think, is still going to be warm. I'm just not. If this rainfall event sets up, then May is going to end up with above normal rainfall for the month. Let's see, so we got some good questions tonight. Outstanding. A lot of activity, too. And I think we're looking for more on. And by just a baseball update, the Mets are still winning 1-0. They're going for their 21st win as they get ready to take over all of the NL East and then baseball. And then they sweep the Dodgers and humiliate them so much so that the overrated player from Japan leaves and gives up baseball forever. That's what's going to happen. All right, so let's see. So overall, pretty good questions. Let me see if we have any more new data coming in. I think the 18Z guidance should start be rolling in. I want to get the one thing I wish I could have gotten in this discussion tonight is a little bit more mesoscale data. Let's see if we got anything new on the NAM here. It's still too far out. The NAM is still showing with the warm front passage on Thursday night into Friday morning, a pretty good wave of showers. Here, let me share this. There we go. So here is what the NAM is showing here. Pretty good warm air transport with this. I like the idea of scattered showers, but I think this might be a little bit overdone with the intense convection. I'm not going to use the HRR. I like using the HRR when we're at the 18-hour mark and lower. So we got some time before that. But basically, around midnight on Friday to like about 3 a.m., we'll have some showers move through. By the time you wake up on Friday morning, they're gone. So unless you have a early shift and you're getting up at 3, you might run into some rain while leaving the house. But then the rest of the day on Friday is pretty quiet. I'm not really expecting much. A few isolated showers, and that is about it. If you're looking for really good thunderstorms, I mean, Baltimore and Washington would make a little bit more sense because there's more instability down there. But even that, I think, is a little bit overdone. Let's see here. Metro in St. Louis this weekend. Any rain? Last I checked, not much. They'll be dodging the worst of this. They've been lucky this year in terms of rain delays too. So let's try something else. Now, this is the European solution. Let's look at some of the model. This is some of the model guidance I have here that I could work with and play around with. Let's take a look at the model blend. This is really cool because it kind of gives me a blend of all the guidance. And we'll go out to the forecast here. And see the model blend, because it includes the GFS here, so kind of a little grain of salt, keeps you at basically that 1 to 3 inch range. But it still shows that overall theme. Again, you kind of have that signal of the divergence and diffluence and then the perfect moisture transport. So that's still showing up in the guidance. Let's see what the GFS does. I'm just curious. See how long that plays out here. Let's see what we got here. Yeah, GFS is significantly drier than the European, but not too far off. Not bad. Oh, you know what? Let's take a look at the ensembles. What does this look like? See, ensembles makes a lot of sense here. Basically got 1 to 3 inches, your nice divergence and diffluence. So look, anyway you slice it, I think we're going to see rain. The question is really just how much. And I think that's all the questions. And it is 8:52. Do we have any more on Facebook or X or anything? Okay. So you got that covered. YouTube looks like I got those questions answered. And look, for all of you guys who are out there getting ready for college, I really do mean it that I'd wish somebody had told me this when I was looking. It's really important that you're comfortable with the class size. Trust me on this. Because if you need a smaller class, and you'll know it, like you can feel it, right? If you need that smaller class feel, it does matter. That matters more than anything else. Any of the flashy stuff, right? Um, and when you go, ask whether or not, as a freshman, if you're allowed to have a room to yourself, and how they work out the roommate situation. Because if you're trying to study multivariable calculus and you have to room with some guy who's like, thinks it's party central, that don't work. Okay. And that's something that you need, that you have every right to bring up. Okay. That you have a right for those boundaries. Trust me, I've been there. Okay. Trust me on this. Speak up if you need to. Will you be putting up a preset map for the weekend? Yeah, once I get a little bit better data, I plan to. Yeah, once I'm getting around 90 hours out, definitely I'll start working on that and putting that out. I just want a little bit more data to make sure that we have a concrete idea of what to expect. So I'll probably start putting out a ballpark on that. I might separate the two. I think I'll probably shoot for Friday to get that all out, because by then I think we'll have more mesoscale data to work with as well. Okay. Will there be live coverage this weekend for the storm hit potential? No. Look, I tried doing live coverage for rainfall events, and it was me and I think it was you, Card, and that was literally about it. Live, huh? Well, I mean, as far as like people interacting on the website, right? I mean, you're always here with me. You're right next door. But every time I try to do a live coverage, aside from a hurricane, really there's no interest in it. Let's just be honest. So I don't do it. Um, I know that there's some people that do a lot with the severe weather, and I don't know why. I just can't get into a swing with that. I'm gonna work on it, but I think it's easier if you're like a storm chaser in the plains because those are more long duration storms, as opposed to here. It's kind of like you either hit on it or you don't, or you sit there all day and wait for it to form, or you don't. Whereas when you're storm chasing in the plains, in the Tennessee River Valley, and all of those areas, you have a pretty good shot of seeing some pretty good convection, and you can create a story around that. So it's a little bit easier to pull off, but it just kind of isn't my niche. But that's okay. Look, we all have different niches. We're all good at different things. I love winter storms. I'm rocking it out for 12 hours straight and all that good stuff. And sometimes 24 hours straight. But when it comes to severe weather and heavy rainfall events, hurricanes, I do really well with. I like that. I like doing those coverages. And of course, you guys all remember what I did with Sandy. Where hopefully I never have to experience that. But I'm just saying that's kind of like my ballpark there. That's my area where I kind of zone in and do well. All right. So with that, I think we're going to let me just double check on questions real fast again. It looks like we got everything answered. Confidence level that European is actually onto something for the next week. I would say 60-44 for this to pan out. I'm just don't I'm not convinced on the intensity of the rainfall, like the 6 inches. I like this, what's on the European ensembles. This looks more realistic to me than 6 inches of rain. But again, we'll continue to look at the data and study it. And with that, as my voice is starting to go, I think we're going to call it for a night. It's practically 9 o'clock. So there we go. Almost a full show. There we go. Thank you, as always, for joining and asking outstanding questions. I hope I gave you outstanding answers. And as always, stay safe out there.